Let's examine the calculation of conductor ampacity for a 400 amp feeder considering specific aluminum conductors in a 4-inch electrical metallic tubing or interconduit. The question involves 6 250 mcm aluminum conductors and 2 4/0 aluminum conductors within the conduit and seeks to clarify if derating is necessary and whether the conductor sizes are adequate for a 400 amp feeder. The key to answering the question lies in understanding and applying the National Electrical Code, specifically Table 310.15b16, which provides ampacity values for conductors under specific conditions. Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in raceway cable, or earth directly buried, based on ambient temperature of 30 degrees Celsius. For the 250 mcm aluminum conductors, Table 310.15b16 indicates that each conductor has an ampacity of 320 amps when installed in a 4-inch ENT conduit. Since there are 6 of these conductors, but only 3 are considered current carrying for the purpose of this table, we can consider the individual ampacity of 320 amps. For the 4/0 aluminum conductors, the same table indicates an ampacity of 260 amps each. The question specifies 2 4/0 conductors, and each conductor has an ampacity of 260 amps, making a total ampacity of 520 amps. However, this seems to have a slight error from the original answer, which states that the ampacity for the 4/0 aluminum conductors is 340 amps, so we will go with the 260 amps according to Table 310.15b16. The next step is to determine the total ampacity provided by all the conductors. The 6 250 mcm conductors each have an ampacity of 320 amps. Giving a total ampacity of 1920 amps for those conductors. Add the ampacity of the 2 4/0 conductors with 260 amps each, or 520 amps. The sum ampacity will be 2440 amps. The question then looks at the need for ampacity derating. Derating refers to reducing the allowable ampacity of conductors when certain conditions exist, such as having more than 3 current-carrying conductors in a raceway. According to NEC 310.15 adjustment factors apply only to the number of current-carrying conductors. Neutral conductors that carry only the unbalanced current from other conductors of the same circuit do not have to be counted when applying the adjustment factors. On a 3-wire circuit consisting of 2-phase conductors and a neutral conductor, the neutral is not considered a current-carrying conductor. A neutral conductor used in a 3-phase 4-wire Y circuit will carry approximately the same current as the phase conductors and must be counted as a current-carrying conductor. The next consideration involves the impact of the neutral conductor and whether to use a derating factor of 70% or 80%. If the neutral conductor carries only the unbalanced load, it is not considered a current-carrying conductor for derating purposes. However, if the neutral carries a significant current, such as in a 3-phase 4-wire system with nonlinear loads, it must be counted as a current-carrying conductor, and derating may be required. The original calculation in the answer overlooked a crucial step. It correctly stated the individual ampacities of the conductors, but incorrectly assumed that the total ampacity of all conductors could be simply added together and compared to the feeder's ampacity requirement. The key is to compare the total ampacity of each size of conductor to the proportion of the load it is carrying. For example, if the 6 250 mcm conductors are intended to carry a specific portion of the 400 amp load, that portion must not exceed the allowable ampacity of those 6 conductors after any applicable derating. The same principle applies to the 2 4/0 conductors. Now let's look at how derating factors should be applied based on the number of current-carrying conductors. If we have more than 3 current-carrying conductors in a raceway, NEC Table 310.15 requires us to apply adjustment factors to the allowable ampacity of the conductors. For example, if there are 4 to 6 current-carrying conductors, the ampacity must be derated to 80% of its original value. If there are 7 to 9 current carrying conductors, the ampacity must be derated to 70%. So, let's consider the scenario where all 8 conductors in the conduit are considered current carrying. The allowable ampacity of each conductor must be multiplied by 70%. For the 250 mcm conductors, the derated ampacity would be 320 amps times 0.70, which equals 224 amps. For the 4/0 conductors, the derated ampacity would be 260 amps times 0.70, which equals 182 amps. The total derated ampacity of the 6 250 mcm conductors would be 224 amps times 6, which equals 1344 amps. The total derated ampacity of the 2 4/0 conductors would be 182 amps times 2, which equals 364 amps. The combined derated ampacity of all conductors would be 1344 amps plus 364 amps, which equals 1708 amps. The final consideration is whether the conductors are now appropriately sized for the 400 amp feeder after derating. If the combined derated ampacity of all the conductors is greater than 400 amps, the conductor sizes are adequate. In this case, 1708 amps is significantly greater than 400 amps, so the conductors are adequately sized, even after derating for the number of conductors in the conduit. To recap, firstly, determine the allowable ampacity of each conductor based on NEC Table 310.15b16. Secondly, determine the number of current carrying conductors in the conduit. Thirdly, apply the appropriate derating factors from NEC Table 310.15 based on the number of current carrying conductors. Fourthly, calculate the derated ampacity of each conductor. Fifthly, determine the total derated ampacity of all conductors. Sixthly, compare the total derated ampacity to the feeder's ampacity requirement. If the total derated ampacity is greater than the feeder's ampacity, the conductors are adequately sized. In summary, the ampacity of the conductors must be adequate to handle the load even after any necessary derating is applied. The interpretation of the code and accurate application of derating factors are critical to ensure a safe and compliant electrical installation. The correct application of NEC tables is essential for accurately determining conductor ampacity and applying necessary derating factors. Always consult the latest edition of the NEC and seek guidance from a qualified electrical professional when making critical decisions about electrical installations.